Hello, this is Ken Ugert. This will be video 15, and we're going to do, this one's going to be a basics in programming. What we're going to do is just kind of start from scratch, create some programs, create a program, and just show you basically how to look at a program or how to create a program. One of the pros and cons with Andover plain English language programming is that no two people will do it the same way. Their programming logic may be a little different. Their names may be slightly different. There's no set pattern for any of this, so when you are reading someone else's programming, you just kind of have to see, you have to kind of know the sequence and where they're going to and in what conditions. So we will create a short program. I have in this first controller here, AE21, it's a blank controller. There's nothing in there. It's freshly online. So what we're going to do, we're going to create a couple points. I'm going to create a new output. This is one I want to control. I'm going to call it fan. And then you go through the configuration. It's going to be a digital point. We'll put it on channel 1. Format's going to be digital, and that's all we're going to do for right now. Basic fan. The other thing I want to do is create a numeric. Just come in there in this white space. There's a video on how to create points and create a numeric called occupied. It's going to be a off point. That makes it a digital point. Apply that. Okay. So we have an output and we have a numeric called occupied. To create a program, come over here in this space again, a new infinity program. We will call it fan control. You can name it whatever you want to. It's going to take you to the plain English development program. Here you have a blank program. There's nothing in there. What we have right now is, like I say, just the fan and occupied points. The way a program starts, when you program something and you come up here to this, when you're done, you will save this. I'll do it now, but it'll come up and there's nothing there. Maybe it won't save it. Put a comment in there first. If you put a comment, it's just a quote mark. You know it's a comment if it's green. It does absolutely nothing. You can put this anywhere in the program. Now if I save it, I think it'll do something. So you see it goes through a checking method. Once you save it, it checks it, determines if there's errors or not. If there are errors, it will tell you what line and where they are. And then it's going to save it and you're done. Now I have a fan program. The beginning of one, we'll say. So to start, when you save this, these are always going to start at the top. Doesn't matter what the program does, it will start at the very first line. And if you know anything about basic programming, where you go from line 10 to line 20 to line 30, you just have line names. You can have, this has lines. You can call them line 1, and you can turn the fan off. First thing you want to do is, if you're working with outputs, you turn it to whatever state you want these things to start in. We want the fans to be off. Okay. So whenever I start this program, it's always going to come up here to line 1 and turn the fan off. Whatever it does after that, it's going to be deciding what the exit conditions are. I'll put some lines here in a minute that will say when these happen, when these lines are true, do something else. So for simplicity's sakes, we'll say if occupied is on, then go to line 2. Then we'll have another line. Copy that. This will be line 2. I want, on this one, I want to turn the fan off. If occupied goes off. So what this does, if I save that, this is a very simple program. If this point becomes on, it's deciding if occupied comes on, then go to line 2. Then you find line 2, which is a line name. These are important that you know line names, difference between line names and points and things. So the line 1 is the very first line. I saved it, it went there. Then it's going to stay on that line until this condition becomes true. So right now, because I have not set occupied to anything, it's still on line 1. To check where this program is, you're going to have bunches of lines on these eventually. But to determine where they are at this time, you'll come over here in the white area and do a right click, and you'll go to configuration. Configuration will tell you some things about this. The state of the program is enabled, and that's important. It is a looping program, which is all we're going to deal with for right now. Looping just means it's going to jump around and can go from one line to another. Fall through just goes from top straight down to the bottom, and you can't go to one line or another. So we're going to stay with the looping program. Now if you go to the runtime, it tells you what the line name, what current line it is on. It says it's on line 1, and it is on line 1. So you would expect, if I were to look at that output for the fan, it should be off, because on every scan, and this is scanning this like 5-10 times a second. I don't know what the scan time is, but it's turning that fan off. You could try to turn that fan on, typing it on, but the next scan is going to turn it right back off, because that's what the program is telling it to do. The other thing that this properties box is telling you, it also says it's on line 1 and it's been there for 2 minutes or 150 seconds. And when this gets to 180, that'll be 3 minutes. So this is not 2 minutes and 165 seconds. It is 2 minutes or 169 seconds. So when you see this goes, when this goes to 180, that'll change to 3. There it is. So you know how long it's been there. If you're diagnosing this and you say, why is it not moving, or how long is it, when did it come there, this is where you do that. So that's an important thing. The other important thing is this current line name, line 1. If you were to look at this, we'll say okay. I'm going to show you why it's not real smart to name these line 1, line 2. If you were to go to, let me refresh this. If you go to the programs and you had a whole bunch of them, and you're trying to see at what point in the program these things are, you can come over here and look at view, and it's going to bring up a list view, and its current line is 1. Unless you're very familiar with this programming, line 1 is not going to mean a thing to you. So I would encourage you on these programs to name them what the purpose of this line of this current code is supposed to be doing. I'm going to call this fan off, because at this point the fan should be off. And if you name these text values like these instead of line 1, line 2, you have to put a colon after these. That informs the programming that this is a line name, not text. I'm going to call this one fan on. And I need a colon after it. So then I have to change these to go to the correct lines. Fan on. I don't have to put a colon after it in the code itself, only if it's a line name. So now if I save this, everything works out. Now if I come over here and I view this, it's going to give me the current line is fan off. So that's kind of important. It's enabled and all this. I'll show you how that looks on a real. Come on down here. I think I lost communications here. Okay, I lost communications there. So what I want to show you is a true why you want to have the line names named in a manner. Here's a rooftop unit that has a bunch of different programs in it. If I were to view this, it's going to come up with the current line name on these. Like I say, people name these different, so their line names won't always be the same. But you can say that the fan, if I looked at this, the fan should be on. The program is calling for it to be on. Should be on cool stage 1. Looks like a compressor has failed, and the damper, it's been initialized. I guess that's what that is. The alarms are at the beginning of the program. The calculations at the beginning of the program. It's checking for fan failures, and it's checking for an override. and here are how long these things have been there. So the fan control has been on there for 8 hours or 507 minutes. So that's a reason to name the names of the something that means something to you when you're programming. Alright, let's go back to this program. So there we are. It is currently on this first line. If I save it, wherever it is in the programming, it'll always come back to here. If I had multiple programs, if I had multiple lines on this, it could be anywhere in the programming depending on which condition became true on this line. To test these, here's another pretty neat feature. You see this, I guess it's a tree. To talk to this one specific program, since if you want to know what these things truly are, you come here and you're going to drill down to where you currently are. You want to ask, I'm at this school and I'm at Air Handler 1. So now I can print some values. I can pull this thing and say, what is your value? I can say print fan. The fan is off. I can say print occupied. Occupied is off. I can say print fan control current line. You can do that too instead of viewing. Now if I want to change this program, if I want to make this do something, I can say, because right now there's no programming called changing occupied. If it were connected to a schedule, the schedule would determine the value of occupied. Right now it's not, so I can change it. We'll turn on occupied. Now, since occupied became on, this is true. It wasn't true before, so it wasn't doing anything. It was just turning the fan off. So it's as soon as that became true, if occupied was on, true, then I'm going to go here. I'm going to go to fan on and find that line name, and there it is. Now if I print fan, it is on. If I print occupied, it is on. If you have commands that you go through, you can scroll up and down with your arrows on this and go back to these same commands. So now my current line is fan on. So this has became true, and it's going to stay there until occupy goes off. So that's basically how programs do what they do. Now I can have other lines on here. Of course, I don't have any points set up yet for anything. Let's think about this for a second. Okay. Let's create another point called safety. It's just going to be a numeric point, and it's going to represent a safety switch or something. A failure, discharge air temperature, or something. Safety. It's going to be a digital .2. Okay. So just doing this so you know where these values come from. Now if we go back to this program, right now it would work. It would work if the schedule if we had a schedule controlling occupied, it would turn it on or off based upon the schedule. Now if we added something else to it, if the fan was on or if it's occupied on and the safety is off, meaning it's normal mode, then go to fan on. So in order for this to happen now, the occupied would have to be on, and that would have to be a true statement, and the safety being off would have to be a true statement. So as long as the schedule was calling for it and there were no safety conditions, it would allow the fan to turn on. Now we kind of come down here to tell it if the safety comes on, we want it to go back off. Okay, so you have AND statements and you have OR statements. You have to realize that AND, let me put this as a comment. You may find programmers that have been in this doing this a while, and they're going to use different terminology than this. They may use the ampersand is the same thing as saying AND. Okay? And the OR statement is an exclamation. I gotta put a comment here. Comment. Exclamation is the same thing as saying OR. For clarity purposes, we will use the AND and OR. It's just kind of habit for older programmers such as me and a lot of others, that they just know what this and exclamation point means. But if you see that, that's what that truly means. So now, if occupied is on and safety is off, the fan will go to this line, fan on. It will immediately turn the fan on, and it will sit here and wait for one of these conditions to become true. If it's this or that, if you have an OR statement, it means this can be true, the first part can be true, or the second part can be true to make this a true. This whole line here would be a true statement. That's the only time these things will move from a condition from a line, if the whole thing is true. So if occupied was off or the safety became true, on, it means you need to turn the fan off. So at that point it's going to come here and turn the fan off. Alright? So there's another way to do that. You can have multiple lines on here that, let's say we want to equals on, then go to we'll call this next line safety on, just for clarification. So we'll create another line, safety on. You got to put the colon right there. Let's just copy this whole line here. What we're going to do is turn the fan off. And modify this. And we'll go back to beginning of the program. It's real important that you understand how the equipment that you're programming or looking at works. There is a sequence of operation for everything that you have. Hopefully you know that when you're looking at this, because you can do some real crazy stuff if you don't damage your equipment, if you don't turn things on off as they should. This is a very simple program, and there's no physical fan connected to it, so I can goof up now if I really had to without damaging anything. So if we look at this, this is a different way of doing this. We're going to sit here on this. If we save it, let's save it. Okay. If I spelled something wrong, let's spell something wrong. Fin. Now, if I try to save that right there, it's going to give me an error. It checks it and says on line 15, column 10, this word does not exist. So you come down here and you can look at where this is right here. It says you're in the first line, column 1. If you come down to line 15 with your arrows, line 15, column 10, that's going to take you to where there's a problem. Then you got to really figure out what the problem is. If you spelled it wrong or what. But if you come up with an error, it's going to tell you that. And if you save it, it should do what it should go through. If I leave a colon off, it's going to say I don't know what that line name is. So it says column 14, column 14, 1, it doesn't know what that is. And on line 10, which is there, column 26, it says I don't know where you're trying to send me. So you got to fix these things before you can progress. There are 2 errors on that. There's only really 1 error, but it had multiple things that were referring to that, causing multiple errors. So you got to figure those out before you continue. If I save that, that's what that does. Now we have kind of the same program, only we got 3 lines. If occupied is on and safety is off, then we will go to the fan on. If the safety is on, it's not going to move from that line, so the fan's still going to stay off. So that's one way of taking care of that. But if we do turn the fan on, it's going to sit here and look at these 2 lines here. How this scans is it looks at the first thing, it turns on the fan. It looks at the next line. It says if this is true, I am going to do whatever this says to do. If that's not true, I will go down to the next line. And if that's true, I will do whatever that says to do. But the first one that becomes true, it's going to do that first. If this safety is on and that's true, it's never going to get to this, evaluate this occupied off. It's just the first thing instantly becomes true, it's going to do. So if occupied was off and the safety was on at the same time, it would come here and it says that's true, I'm going on into this safety line. Alright, so now if you were to go back and view this program, you could, well, safety's not off. Let's turn safety on. Turn on safety. Now we go back here. That's like a snapshot, so yep, well, it did go back there, didn't it? Come back here and view that. It's going to tell you that the safety is on. Meaning that if you had a whole bunch of these things and you're looking at the fans and saying, well, which ones are having problems and why, that current line name again tells you what's going on. The fan is not on the fan on, but it's on the safety. And if you know your program, you know that on that line that fan should not be on. So let's go back to this program. You can print the fan, it should be off. And it is. So if you have some safety things, if you have some things that you have to put these in like priority when you're putting a list of these down through here. You can have 5, 6, 7 what I call exit conditions, but you have to put them in a priority of this one is the most important thing. If this happens, something's going to go really bad. The next thing can be something less of a problem, then finally you can put your less problematic things further down the line. But the first thing that comes true on there, that's how that's going to function. It'll do that, go to that line name instantly. There's another thing that timers are something you'll see quite often, so that you don't bang things on and off fast, on off pumps and fans and things. They don't like to be cycled on too quickly. Compressors, if you turn a compressor off, you like to have that off for a time. So there are time delays. What you'll see, what these will be, if you incorporate these, we'll say if these things are true and a delay of 5 seconds has passed, then I'm going to go to fan on. What you have, let me comment these here. Time in seconds equals seconds. You got minutes. Time in minutes. Minutes. Time in hours. Hours. And you also have time in days, which I've used a few times. Okay. So there's what you have for those. You have to, if you want real precise delays, you'll use time in minutes, time in seconds. Because I want to move this, have a minimum delay of 5 seconds. Time in seconds greater than 4, because 5 is not, if I put 5 there and I truly wanted to move on 5 seconds, that wouldn't happen, because time in seconds is not greater. 5 is not greater than 5. It has to be greater than 4. Let's see if I'm explaining that right. Let's see. Let's save that. Here's what you're looking at. Here's your timer. When I'm saying, if I'm on this line and these are true and it's been more than 4 seconds, this is what you're looking at, this time in seconds here. But because my safety is off, or on actually, it's not going to move from this value. Let's turn off the safety. Then we'll try to get to that configuration quick. So at 5, okay, well it changed before I got there. Let's delay that a little bit. Cancel, cancel, cancel. I think I lost communication again. Hold on. Okay, I lost communication again. If I were to delay this, we'll put 10 seconds in there. 10. We'll put 14 seconds. How about that? So now if I save this program, it's fan off. Like I say, it starts on this very first program. Occupied is on, safety is off, but I have to wait 15 seconds. At 15 seconds, it goes to this different fan, and it's going to run there until either the safety becomes on or occupied goes off. Now if I turn the occupied on, let's see, turn off occupied. And that should have went back to fan off, and it did. 6 seconds. Now it's waiting. Now because occupied is off, that's not true, that is true, and that's true. But this whole statement here has to be true before it will allow this to go to fan on. Now immediately, there's no delay because it's already been on that line for more than 14 seconds. Immediately when occupied goes on, it's going to immediately go to fan on. So there would be no delay there. The other place you might want to put a delay is, let's see, if the safety just blips off, you wouldn't want it just to bang on and off, would you? Well, it wouldn't do that anyway, that program. But anyway, that's in a nutshell, that's kind of how things run on this. And two people can program these things have the same information, and they're going to be totally look different. Well, that's 40 minutes of basic programming. I could go on for a long time on this. The important thing is just to know how this thing is going to react when the conditions become true. There's lots of keywords There's a great document. I'll try to put that link in the below possible. But if you look at that document there, the Plain English Language Reference Guide, it gives you a whole lot of information about how things work and why they work the way they do. Keywords, programming, and things like that. If you have any questions, specifically, I don't know that I can help you specifically once you got it, but if you're in our school system, I can certainly help you with that. But there's also this help up top here. I usually find it more confusing than anything else. But that's available to you, and that explains things, some things. But like I say, this is all non-BACnet stuff. So if you have BACnet, some of this stuff may not be the same. But like I say, if you have any questions, let me know. And I hope this clarifies a little bit. I'll do some others on some additional programming things that you will see, such as parentheses and how things are grouped together like that. But this is the basics. So thanks for watching.